Good morning, everyone. The title of my talk is Mapping Time in Antarctica, an experimental approach to synchronism. My name is Maria Ximena Senatore Connolly, and I am an archaeologist and researcher at the INCIPIT-CSIC in Santiago de Compostela, Spain. I apologize for not being able to deliver this presentation live. Because of scheduling conflict, I had to record it in advance. If you have any questions or comments, please feel free to write to me by email. A widespread assumption is that human occupation in Antarctica is temporary and episodic rather than continuous. The Madrid Protocol reinforces this idea with the principle of reversibility. Yet, materialities tell a different story. As I have argued elsewhere, things put down roots in Antarctica while people rotate. To address this contradiction, I propose an experimental approach that shifts the focus from people to things and from space to time. Maps have long shaped how we visualize human presence in Antarctica. These spatial approaches are valuable, but they overlook time as an equally crucial dimension of permanence. Studies of Antarctic infrastructures usually tell us where bases are or when they were founded. What they do not capture is their relations. For example, how long they have coexisted. In my work, I foreground temporality as a lens of analysis. Permanence is not only about whether something remains in place, it is also about how long it endures and with what other presences it coexists. From this perspective, duration and simultaneity become key indicators of permanence. The Madrid Protocol articulates a desired horizon. Infrastructure should be temporary, removable, and leave no trace. Yet, little attention has been paid to whether this principle of reversibility is reflected in the actual temporal dynamics of Antarctic stations. I analyze permanence through synchronism, the shared years of activity that link stations into networks of coexistence. From this perspective, reversibility is not a condition to be fulfilled or unfulfilled, but a normative regime whose effectiveness can be tested against the material assemblages it produces. Instead of dots on a map or linear timelines, I use graph theory to capture these dynamics. Each station becomes a node, and two stations are connected if they were active in the same year. More generally, the strength of a connection between two stations is proportional to the number of years they coexisted. By modeling synchronism in this way, I can visualize the network that characterizes the temporal coexistence of Antarctic stations, calculate metrics that quantify density and structure, and use these tools to evaluate whether Antarctic presence align more with reversibility or with permanence. For this study, I compiled a dataset of more than 100 stations. I generated annual graph linking all bases active in each year, and for every graph, I calculated metrics such as density and connectivity. Then, to simulate a reversible model of Antarctic bases, I created a secondary database identical to the first, but with the station disappearing after a maximum of 20 years. I repeated the same analysis, generating annual graphs and metrics in order to characterize the expected network dynamics of a reversible model. When I compare the reversible model with the empirical one, the difference is immediately visible. Both models see the same bases appearing over time, sorted counterclockwise, but their temporal relations differ dramatically. In the empirical model, the network becomes increasingly dense. The strongest connections describe the enduring relationships between some of the oldest stations, overshadowing any temporal structure among newer ones. By contrast, in the reversible model, the network remains narrower. It separates older from newer stations more clearly, while still showing the structure among groups of coexisting ones. These slides make the comparison more intuitive. Above, the empirical network for 3 decades, nodes and edge multiplied, and the system becomes denser over time. Below, the reversible model for the same decades. Nodes still grow, but the edges cluster narrowly around the main temporal axis. Placed side by side, the contrast is striking. The empirical pattern clearly aligns with permanence and accumulation, not with reversibility. This contrast is perhaps best captured by graph density. Both models start with very low density, but in the empirical model, it rises steadily year after year with no sign of slowing down. In the reversible model, density begins to slow after the 1990s and plateaus after the 2010s. The absence of the expected plateau in the empirical data is one of the clearest signs that Antarctic basins do not fit a reversible model of occupation. In conclusion, this study shows that Antarctica is not a territory of reversible and short-lived interventions. Infrastructures tend instead toward cumulative and enduring permanence, even when their stated aim is to be temporary or removable. What emerged is a dense and lasting assemblage of infrastructures, whose persistence challenge the environmental norms of the Antarctic Treaty System. In this sense, reversibility functions less as a material practice than as a regulatory fiction. Thank you very much.